Dear colleagues, hello. Let me introduce myself. My name is Sergii Lysenko. I present Khmelnytsky National University, and I'm going to tell you about the technique for cyber attack detection based on DNS traffic analysis. So, today we will talk about cyber attacks, spreading known techniques and new challenges. Also, we will mention about background, our TIF solutions, our previous researches. Of course, we will talk about our main impact of research made in the solution, and the result, some performance measures of our proposed technique. So let's start. Today, corporate area networks and information security are one of the most important problems of homeland security, as they affect the economy, citizens, and whole societies directly. The number of successful cyber attacks performed by malware on infrastructures, civilians' financial system is still growing. One of the reasons lies on the inefficiency of signal-based approaches for cyber attacks detection. Known anomaly-based detection techniques sometimes demonstrate low rate of efficiency and high false positives. Today, we know that data breaches exposes more than 4 billion records in the first half of 2020. Also, hackers attack every 40 seconds, on average 2.2 times a day. Another fact is that almost 60% of companies experience social engineering and phishing attacks. And more than 100,000 groups in at least 150 countries and more than 400 machines were infected by the WannaCry virus in 2017 at a total cost of around $4 billion. So let's talk about our previous researches as a background. Our team have its own history of the cyber attacks detection techniques, and starting from 2011, the very first idea was to detect cyber attacks using multi-agent systems, and the first results were that the botnet detection using agents communication within a corporate area network. Further, evolution of our techniques were by identifying the botnets which used such evasion techniques as cycling of IP mapping, domain flags, fast flags, and DNS tunneling. During previous several years, we improved our approaches and produced self-adaptive system against cyber attacks. It obtained an ability to recognize the cyber attacks, taking into account the host network activity and the captured network traffic. So let's talk about the proposed technique. A new technique for cyber attack detection based on DNS traffic analysis is proposed. It enables the proactive malicious request detecting in corporate area networks based on DNS protocol and is aimed to identify and log the malicious domains. The method is based on detecting anomalies in the DNS data exchange, and the process of malicious request detection is based on the use of the isolation forest algorithm. The process of detection consists of two main phases: training and detection. The training phase includes the following steps: knowledge formation about the benign requests by the users, which use the DNS data exchange based on benign traffic samples. So we have to present knowledge as a set of feature vectors and construct the isolation tree structures based on features vectors based on benign traffic samples. And the last one is passing through the isolated tree structures for each benign traffic samples in the test set and calculation the anomaly score using the isolation forest algorithms. The detection phase includes the steps: monitoring of the network in order to gather the features that may indicate the attack's presence, formation of the set of feature vectors, and definitions an anomaly, the feature vector whose estimation exceeds the predefined threshold depending on the domain to which the analysis is applied. And having the result, we have to block execution of malicious requests in the computer system. Isolation forest algorithms allow to detect the anomalies by the recursively generating partitions on a data sample via the selection randomly of a feature and selection randomly of the limit value for the feature between the evaluated minimum and maximum values permitted for the specified feature. In order to evaluate the anomaly score of the analyzed data, the observation that isolated tree structure is equivalent to the structure of the binary search tree, which is taken into account. In order to normalize the value and to perform the anomaly score evaluation for the given sample, we have to use such a quotation. And it was mentioning that for any given traffic sample, we know if the result is close to 1, it's very likely to be an anomaly. If the result is smaller than 0.5, it's be likely be a normal value, and if it's around 0.5, the sample doesn't have any anomaly. The data gathering stage involves such procedure. If each log file describes DNS traffic during the specified time window, and it can be presented as a tuple, which includes timestamp, MAC address of the infected host, the full required domain name, and the set of the resources records in the answer section of the DNS response, and the number of the resources records, query type, for example, A, NS, PTR, etc. Presented in such a way, DNS log strings are to be grouped by the primary domain, which can be grouped the primary domain for some domain name, a group function for the DNS log strings concerning the primary domain name and time for data gathering, and a set of the DNS log strings for each domain name grouped by the primary domain names, where taking into account a number of the data samples. The feature exfiltration procedure can be presented as the function, and also feature vector can be presented as follows in our slide. And its set includes feature vectors and takes into account total number of feature vectors of all gathered information. The DNS-based text detection procedure takes into account the training phases, uses a set of constructed feature vectors, and outputs a set of anomaly scores for each feature vector. The input data for the classification algorithms is a set for each domain name and for a period time, and the result is anomaly score rated from 0 to 1. The output of the learning phase is a set of anomaly threshold corresponding to each analyzed feature vector, and they are being applied to new data. The testing phase deals with the obtaining of new samples where to be proceeded by the algorithm in order to estimate the sample score using the iForest function. If we obtained value which exceeds the anomaly score, The sample is considered as anomalous, and the domain will be considered as a malicious domain and is to be blocked. So, firstly, we know that domain names that are to be classified can be assigned into two categories: malicious and legitimate. As soon as these domain names are defined as malicious, the security scenario for the attack's mitigation is to be applied in order to block the malicious queries in the network. Let's talk about experiments. For the purpose of technique efficiency evaluation, a number of experiments were held. The aim of the experiments was to estimate the ability of the method to detect malicious DNS queries. To train the system, the dataset was used. It presents the benign users' DNS traffic, and to test the system, a set of DNS traffic tools were used to generate malicious traffic, such as DNS-cat-p, which is able to generate A-type queries. DNS-cat-p enables using SSH tunneling, including SOCKS, proxy, etc. Tunes generator, which enables to obtain CNAME records. pseudo-p exfiltration tool for DNS queries, DNS to TCP query generator, TCP over DNS tool, which enables to support LZMA, TCP and UDP traffic tunneling. Iodine project, it's a DNS tunneling program which uses a tune and tap interface for the tunneling. And for the purpose of experiments, CNC service imitation, the set of fake domain names was registered. Those servers made it possible to simulate malicious activity, such actions as command and control traffic transfer using DNS tunneling, cycling of IP mapping, domain name, changing, etc. Network activity was about 100 users was emulated. Here you can see the test result, the isolating as anomaly feature vector presented as a point in the Gaussian distribution. And here you can see the result of a timeline of the DNS traffic from the malicious activity before attack and after the detection and the security scenario appliance. On this slide we can see that the experiment results for different DNS attack tools, taking into account not only malicious DNS traffic but also benign traffic. And here you can see the result of sensitivity, specificity and detection efficiency measures as a result. So proposed technique demonstrated that detection efficiency was in the range from 94 to 99% for different types of DNS, malicious DNS queries, and false positives rates not exceeded 4%. As a discussions, it worth mentioning that system may be further improved by choosing a more refined set of malicious sample for each type of DNS traffic, and to increase the classification accuracy, different machine learning algorithms may be employed. And as a matter of fact, the mitigation potential of the system also can be improved by addition and new features of malware and relevant to the malware and providing corresponding security scenarios. Thank you for your attention.